In the timeless art of violin playing, each note offers a world of possibilities. A decision between 4 different strings, more than 12 positions, and only 4 fingers. Imagine holding a violin. For a single note, you can choose a string, each offering its unique sound. Then, within that choice lies the position, simply moving your hand up or down the fingerboard. And finally, the selection of finger, each lending its unique voice to the note, altering its warmth and character. This dance of decisions, a balance between artistic expression and playability, has been the violinist's challenge for centuries. Our project has been a true adventure, mixing traditional violin annotation techniques with modern technology. We have made a tool to serve as a daily companion for violinists, a tool that brings recommended digital annotations for string selection, hand position, and finger placement directly to the violinist's sheet music. By using the k-nearest neighbors algorithm for prediction, our project seeks to meld the precision of machine learning with the artistry of music. Even though our results vary and the accuracy isn't perfect, we have made an attempt to connect the old ways with new possibilities. As we transition from the physical to the digital, from the strings of the violin to the keys of my computer, please let this not just be a presentation, but a doorway to a new chapter of violin playing, where the past meets the future.
Hello everyone, Artemis here. Back to the regular voice now. So, let's jump straight to the presentation. And first, a question. How to get from here to here? And look, there is much more than just the color of the page. You can see the bunch of zeros, threes, ones, twos, fours, all over the place. And I can also see hours of thoughtful work. That's exactly what we're trying to predict and recommend, the fingerings. And you may ask, why is it that hard? So let's take a note, a mid-range note, C4. It can be played on 2 possible strings, A or D. We'll take the most common positions, 1, 2, 3, and 4. It appears that C4 can be played in 4 different ways on the violin. Let's keep that in mind. Now, let's look at violin concert range. 4 octaves. Each octave consists of 12 semitones. If we do the math, it adds up to 49 concert pitches. And if you consider that each note can be played in 4 different ways, it adds up to a big number of combinations. So how to choose the best fingering? Definitely, the most contributing factor is a music context. It's simply the notes that we can collect, analyze, train our model on, etc., etc. We were mostly focused on this part. Now a few words about dataset. Contains 10 violin pieces, annotated by 10 professionals, totaling over 200,000 notes, available publicly on GitHub. And now the example, recommendations for C4. We have a small excerpt, only 3 notes, B3, C4, and D4. Our current note for prediction and recommendations is C4. We don't know everything about B3, or we have already predicted everything. And we know almost nothing about D4, except pitch, as well as for the note C4. Here is the representation of the note. There are 4 features: pitch, string, position, and finger. Now you can see the same information on your screens. And the initial step is a feature engineering, adding some context. So we know already about the pitch. We want to predict string, position, and, the most importantly, finger. But first, the context. We add all information we know about the previous note, B3, and the next note, in this case, D4. After we have added all the context features, each entry goes through a multi-stage canon prediction. There are 3 canon models: string model, position model, and finger model. So for each entry, for each note in the score, we predict first string, then position, and finally finger. Then we do this process again and again for each note. In this case, we're processing D4. It already knows everything about C4. And now, a small demo. A simple C major scales to octaves. So let's open the terminal. Let's launch our canon multi-stage prediction. Already prepared the name of the file. It was formatted in music XML format. 28 notes, so 7 bars, 4 notes each. We want to proceed, creating context features, predicting. Then it will apply a small domain-specific algorithm just for range sanity check, and boom! Prediction successful. We have an output file, and we can open it in our notes editor or score editor and see the result. So all the notes has been annotated. We can see all the fingerings. That's a success, I think. Thank you so much for your attention, and see you in the practice room.